Okay, I'm talking today to Professor John O'Quigley, who I'm sure many of you are familiar with already. John is Honorary Professor of Statistics at University College London. His career began in the Mathematics Department at the University of Leeds, after which he moved to France. Following that, he worked through the early 90s up until the late 2000s in the United States as Professor in the Department of Mathematics at the University of California in San Diego. He also worked at the University of Washington and the University of Virginia. Back in Europe, he worked at the University of Paris Sorbonne until more recently taking a position at University College London. So, with that being said, thank you very much for joining us today, John. Very much appreciate it.
Thank you, Chris, for the invitation. It's nice to see you again, and just let me say how much myself and many others appreciate your efforts in helping nurse Lucy Letby.
Thank you. Same to yourself as well. So we're obviously going to discuss Lucy's case primarily today, but I want to talk a little bit about your background first. It's always interesting to me when I speak to statisticians or mathematicians how they initially became interested in mathematics and statistics. So could you tell me a little bit about that?
I guess I always found mathematics relatively straightforward. When I went, for some reason, I don't know why, because a lot of people don't care for mathematics, but when I went to do a degree, it was actually in physics. So that's how it all began. I started out in physics, and I really found physics quite a challenge, a big challenge. And I struggled to get any of the experiments to work. And at the same time, this was at the University of East Anglia, they made all of the physics people take all of the math classes. They said, you're going to need mathematics later on. And so like everyone else, I took the math classes, and they just seemed so much easier than the physics. So I took the easy route, which was just to stick with the mathematics. And then I didn't have to worry about experiments, because it was, the nice thing about mathematics is you come up with some basic structure. And if you get stuck, you can just go back. You just step back, and then you just start again from wherever you were. So I always found that relatively straightforward. And I think, like a lot of math people, actually, I would say young students, I come across this a lot in my teaching career. A lot of a mathematician, when they're young, they like it, they like the topic, but they find it hard to imagine how it can be applied to anything. And in fact, you realize it can be applied to so much. And I was keen later on to figure out ways that the mathematics could be of value. And of course, what an obvious route is statistics, probability and statistics, because these do crop up in everyday life, which I find interesting. And I then got involved in working with medical colleagues, clinical trials. Essentially, I spent a lot of time on the methodology of clinical trials, how to structure a clinical trial in such a way that you safeguard the interests of the patients as best you can, and you learn as much as you can from the trial itself. So I've spent probably much of my career working on those kind of issues, and some other things, genetics. There's so many areas you can apply both statistical theory and mathematical theory to. So I would say that's it, mostly clinical trials, genetics, some other issues that arise in medicine. And of course, very recently, I became involved in some of these legal questions, which I find quite fascinating, to be honest, very fascinating and scary at the same time, of course.
Absolutely. Um, so can you just give me a few examples of projects that you worked on before your interest in the Lucy Letby case in your professional career?
Well, as I said, clinical trials has been a main interest. We worked a lot with colleagues in the United States on methods which really try to safeguard as best we possibly can the interests of patients who are enrolling for the first time in a clinical trial. So these are usually with experimental new treatments. These are treatments which have not been used, And in many ways, in oncology anyway, we're talking about cancer patients, and they will often have tried therapies, they will have tried everything. And so they're out of options. And then the question is, okay, they're going to try an experimental treatment because they think that's the best shot, and it no doubt is. But our question is, you cannot treat people like guinea pigs, obviously. You have to nonetheless do everything you can to safeguard their interests while learning as much as you can about the treatment. So that's quite a balance. It involves a lot of issues, some of them very medical issues. And of course, those are not ones I can make any decision about. We have medical colleagues, they will make medical decisions, but we can, help our medical colleagues to see what are the consequences of various actions they might envisage in terms of trying to learn something from the experiment. So I spent a lot of time on that, and I recently spent some time working on BRAC. I'm not sure if you've heard of BRAC, but BRAC is breast cancer. I think it just means breast cancer gene or something like that. And I became interested in that maybe some 20 years ago, when there were some attention was focused on some famous people like Angelina Jolie, and there were several others who decided to have their breasts removed because they had some gene. And it turns out that this is nowhere near as hazardous as is thought. It's nothing like as hazardous. So I did work on that, and I've written some papers on that that were published actually in genetics journals, which is obviously not my field, but that was nice to get them in there because it means they are taking seriously what you're saying. And I think I felt that as if that was quite helpful. I'm still interested in that. There's still a lot of work to be done there to try and really evaluate correctly the additional risk that might be encountered by carriers, so-called carriers of these genes, because certainly there was a lot of, I would almost call it panic and alarm about, presence of these genes when there's no real grounds for that. In actual fact, if you look at it more carefully, if you think about analyzing what information we have more carefully, then you find that there's not really anything to get over anxious about. So I've worked quite a bit on that. And then, I spent a lot of time teaching when I was in the US. I was in the math department, and we were told we had to cover all areas, which is interesting. We had to teach, every area of mathematics, which is sometimes, I remember quite well that, some of those classes, you were just one class ahead of the students. I can admit that now, but because it's not a topic you're familiar with, or you may have touched on it at university, but many, many years later, when I'm teaching, I taught some classes on number theory, and I couldn't remember any of that stuff. So I was literally, we had the book, and I was half a chapter ahead of the students. But I managed to get through, and I learned a lot in the process. Actually, that's how you learn things, actually, teaching things especially when the students, they throw in some really challenging question.
Mm.
And that's when you realize that, wow, this is not as straightforward as I thought it was. So I enjoyed that a lot, and pretty much that's the kind of thing I've been doing.
That's great. So clearly, we're going to talk today about statistics in the Lucy Letby case. And I just want to mention, we were discussing this before we started recording, that there has been this claim online that statistics are not important in the case and the shift chart is not important in the case. I think that we have demonstrated now that this is completely untrue. We know statistics are central to this case. We know the shift chart was used right at the start of the case by Nick Johnson and was central to his arguments. We know that a lot of inference was made from the shift chart that Lucy Letby was on duty. And in a lot of the latter cases in court, they didn't even seemingly need to prove anything. They just referenced the shift chart.
Yeah.
So I want to establish that as a bit of commentary to begin. But the first question I want to ask you is how and why you became involved in the Lucy Letby case.
Yeah, well, actually, I don't live in England. I have a position at University College London, but I live most of the time in France. So I only heard of it indirectly through people I know there, and when I was visiting, when I'm in London, but it was quite late in the day I heard about the case. And my initial, immediate reaction really was, this sounds so much like the Sally Clark case, which I do remember quite well, which was really shocking, a shocking case altogether, about the most absurd use of statistics I've ever seen, where a pediatrician known as Sir Roy Meadow had no clue, of course, about statistics, but everything they based on his calculations, which had made no sense. And on the basis of that, they condemned Sally Clark to she was jailed, and she was a young woman, young children, and well, she never recovered. She died. She never recovered from that. And at the time, I think that was in the early 2000s, around through the 2000 years, and that was such a shock. I thought, well, they're using statistics to lock people up. This is terrible. And then, of course, there have been other cases, but they've been in other countries. Interestingly enough, Lucia de Burgh has almost the same name as Lucy Letby, and her case so closely parallels that of Lucy Letby. It's really chilling. But there were cases in other countries, and there was a case in Italy, and they all have the same basic structure, and that is the whole case, not just a part of it. The whole case is leaning on statistics. Whatever they say, they add things to it. But initially, they admit that nobody saw the person accused ever doing anything wrong. Nothing was observed by anyone. So there's no witnesses. There's no substantive material evidence either. All of this comes later to try and build a case. But at the time, there is simply nothing pointing at the accused. And so what they do, they come up with two strands, both of them very doubtful, of course. But the two strands are, number one, to prove, in inverted commas, because I would not accept it as a proof at all, but to try and convince people at least that the increase in rates of adverse events, call them suspicious events, or they may be more objective if they correspond to deaths. In the case of Lucy Letby, I think in 2013, am I correct? 2013, I think it was 2013, there were, correct me if I'm wrong, but I think there were 2 deaths in the unit that year. The year following that, there were 3, so you can count, there's an average around 2.5. But then in 2015, there were 8. So that sounds like an awful lot. Actually, it's not. If you analyze things correctly and take into account all of the other units across the country, and you realize you're looking at the worst performer, it's not nearly as bad as it sounds. But in any event, on the basis of an impression, and it is an impression, you've seen 8, whereas you only expect to see 2 or 3 or maybe 4. You've seen a spike, which is referred to as an inexplicable spike. You've seen a spike, and then if everybody is convinced that the only reasonable explanation is criminal activity, whereas, of course, as we know, there are many others, that's the most unlikely explanation, actually. But once we are all convinced that this spike is the fruit of criminal activity, then there's only one remaining question, and that is who? Who? And that is answered by the chart. You'll say, well, listen, nobody saw anything, but if you look at this chart, you'll see that the person who was thereabouts, each time we feel a crime took place, we've got a common denominator here. And they use that term, actually, common denominator, and it must be them. So this is pretty astonishing when you think of it. All of the evidence is completely indirect. People sometimes say circumstantial, but it's much more than just circumstantial. It really actually has no bearing at all on the case. It doesn't have any I mean, being present doesn't mean anything. People have to be present. These are nurses. They're supposed to be present when things are going wrong. The spike itself is something that can be analysed. And by the way, Chris, I might say that the analysis of a spike, of what we call an outlier, is a rather tricky statistical topic. It's not easy. So I cannot just say off the top of my head, oh, that looks like an outlier, yes or no. That requires work. That requires quite a lot of work, actually. So certainly to say, oh, this is something really odd, it can only be criminal. That is not warranted in any situation. It is not warranted. It would be warranted to call us as statistical help and say, listen, we are concerned. We don't know what's going on. Would you come and help us? That's a great idea. They should do that, of course, as they should get help from lots of people. And at the Countess of Chester, they did get some help from the Royal College of Pediatrics and Child Health. They called them in to help, and they did a great job, I think, with their first report. And that's what's needed. I think things need to be done more calmly. And certainly there are problems. Nobody's saying there are no problems, that nothing happened. Things happened. But I think people need to be calm and look at it closely and carefully and try to figure out, okay, how can we explain this?
Yeah, absolutely. So we're going to discuss the statistics in more depth, and I know John is still doing work on this, so not all of which we can discuss, but we're going to discuss everything we can today, and we can always get him back in the future. So we're going to begin this just by asking a very simple question. Why do you think the statistics were so badly flawed in the Lucy Letby case?
Well, for the reasons I guess I just said, it's difficult. I mean, it's like any activity, I suppose. Doesn't matter what the activity is. If you're trying to do it correctly, it always needs care, and that's not just for professional activities. Pretty much any activity, you need to take care, think about it, think about what you're trying to do, and think about what it is we're looking at. That certainly was not the case here, that despite there's no evidence of a spike, number one. Of course, that's statistical. There is no statistical evidence of a spike. But since then, I came to that conclusion quite some time ago. But since then, of course, we have the report of Shu Lee and the report that Mark MacDonald submitted to the Criminal Cases Review Commission, the CCRC. And that details very, very carefully all of the incidents that were in the charge sheet against Lucy Letby. Looked at all of them, and so they go way beyond the statistics. They actually say what happened. This is what happened. These are the explanations. And so I think that was one of the first things that was surprising, really, that the pathologists' conclusions were just overwritten. I would think there needs to be some procedure for that, you would imagine, to just override the pathologist's conclusion, say that must be wrong, it's something else, it's a murder. I don't know what the procedure is there, but it does appear that there was nothing required. They just said the pathologist got it wrong, and this is the new explanation. So that is obviously concerning. So I think that those really they got off on the wrong foot right from the word go. I don't, to be honest, I don't really believe that statistics has any major part to play in an investigation like this. I think it should be the conditions at the hospital. It should be various factors which are known to be involved. Statisticians could probably help, but I honestly feel that the role we can play and that we ought to play should be fairly minor. I think at this point it's become rather more important because we have to show that there is no evidence pointing at Lucy Letby. But I think in a normal situation, I think they could say, listen, there's problems here. Let's look at them dispassionately. Let's try and get some idea as to what can be going on and not immediately come to this conclusion that there has to be criminal activity and next to use a very, very dodgy procedure. I will show today, I hope we have time, but I can show just how dodgy the procedure they used is, because actually we can use it to frame anyone we want. anyone, you just choose a name and I can get the chart for them. It's as easy as that. So it has no real value. But then maybe to go back to an earlier question, if I may, Chris,
Please do.
let me, because I have with me, by the way, for your listeners, I'm sure that all of them will be anxiously looking forward to your book, as I am. I'm sure they're no less anxious. But in the meantime, for those who are not familiar with the article of Rachel Aviv in the New Yorker, I cannot recommend that article too highly. It really, in a relatively short space of pages, she manages to get so much information across there, and then you can come to your own conclusions. But it's a very, very well written piece. So I have it with me, and I'll just quote a couple of things just to try and underline the importance of that chart, and because it comes across here. And right early on in her article, she says, "Am I reading the right thing? Sorry."
That's
Oh,
okay.
yes. It says, no one ever saw Letby harming a child, and the coroner did not find foul play in any of the deaths. Of course, that we know. And then she says, well, the case then gathered force. Those are her words. It gathered force on the basis of a single diagram shared by the police, which circulated widely in the media. That is the chart, you know? And Nick Johnson told the jury in his opening statement, if you look at the chart overall, the picture is, we suggest, self-evidently obvious. It's a process of elimination. And a couple of things at the very end of this paper here, where she picks up Johnson's examination, cross-examination or interrogation, I don't know what you call it, of Lucy on the stand. And this is what he says. Do you agree that if certain children were attacked, then unless there was more than one person attacking them, you have to be the attacker? That's what he said. Where's he getting that from? He's getting that from the chart. And then he continued, if they were actually attacked by someone, then the shift pattern gives us the answer as to who the attacker was, doesn't it? Well, Lucy, of course, does not agree. And then he insists, he doesn't drop it. So let's say if baby 5, 8, 10, and 12 were all attacked, if the jury looked at the medical evidence and they were all attacked by someone, and you are the only common feature, it would have to be, wouldn't it, that you are the attacker. So that chart, they can say whatever they like. You know, I know the main prosecution expert witness insisted that statistics was irrelevant. They didn't insist that at the time, of course. That was afterwards. But if the statistics are irrelevant, I'd like to know what is relevant, because even if we accept that there was some evidence of poisoning via insulin, or that babies may have died because of air embolism, either in the stomach or in the bloodstream, then who? It still does not point to anything. It could be anybody. Nothing points at Lucy. The only thing that points at Lucy is the chart. So the chart is it's absolutely crucial. In my opinion, it's the whole thing, you know, not just a small part. It's really everything. It's the essential part of the case.
Yeah, absolutely. So I believe you've got some slides to share with us
Yeah.
today.
Well, we
Um,
can, yeah, of course.
can we get into those?
I'm going to try and see if I can share it. Let me just begin.
We have rehearsed this, but we're obviously relying on technology today, so I'm sure it will work out okay in a second.
Yeah, I'm just trying to find out. Hang on a second.
Yeah, no worries.
Okay, share screen. Here we go. Share.
There we go.
Here's the chart. So this is the famous chart. And as we can see, anybody looking at this chart will be struck. The thing that jumps out at you from the chart is, of course, the row of dots or crosses for nurse 23. We have nurses 1 through 38. Nurse 23, as you may well guess, is Nurse Lucy Letby. But it gives the information of presence at events. These events, listed 1 to 25, were described as suspicious events. They include the deaths, and they include what were considered to be suspicious events. Now, of course, this is a whole issue. How do we define suspicious? Well, here, at least, what was presented to the jury, we had actually 61 events in total. We don't see the other 36. We only see these 25. So the non-suspicious events we do not see, but we do see the 26 suspicious events and the presence of the nurses at these suspicious events. And of course, what we see is that nurse 23, Nurse Lucy Letby, appears to be always present whenever something goes wrong. And that's why people said, oh, she was always there. She was always present. And in fact, maybe he said this in error, but Nick Johnson, he said, he turned it the other way around. He said, listen, whenever she's there, something bad happens, which is not consequent from this table. From this table, all we can say is when something bad happens, it appears that she's there. But when she's there, she's also there when non-suspicious events take place. We do not have that information in this table, so we cannot say whenever she's present, something bad happens. There's no basis at all for that. And that is a statement that he made. But these are all things that can be investigated. And I did to some extent. And the most interesting thing in this chart is the only part of this chart that tells you nothing is the continuous row of dots for nurse 23. Now, of course, everybody immediately, including myself, when you first see it, you think the very opposite. You say, well, the rest is just whatever happened. It doesn't matter very much. This is what really counts, is nurse 23. But in fact, it's the only thing that does not count. I'll explain that to you as we move along. But there is a treasure trove of information in all of the presence for all of the other nurses. So if we look at nurse 1, she was present at one event. He or she, I tend to say she, but obviously there are male nurses. So he or she was present at one suspicious event. So a very simple, elementary, rough and ready calculation for the probability of being present given an event is suspicious is 1 divided by 25. And the same is true for nurse 2. Nurse 3 was present for 2 out of 25. So we can have a rough estimate of the probability there, 0.08%. I'm sorry, 8%, 0.08, which is 8%. So we can work that out for every nurse. We get a distribution. And this is very, very informative distribution. I can tell you for various reasons that we'll get to. That tells us a huge amount. We have a huge amount of information there. So for any given individual nurse, of course, it's noisy. We see 1, we see 2, we see 3. That information is somewhat imprecise. But once we have a lot of it, then we can smooth all of this information. And for the data scientists or statisticians listening, they will know exactly how to do this. This is the kind of thing they do all the time. And this is something we can easily do. And we can get information on presence for the unaccused nurses or the non-accused nurses. And where this gets very interesting, and we'll see this in a minute, is I can link the information on those nurses to what I need to know about nurse 23. And we do that using a device known as the relative risk. This is something that epidemiologists use all the time, are very familiar with it. It's certainly used also in clinical research, and it just looks at the ratio of different events, the ratio between different groups. And the groups we have in mind here are two. Group 1, if you like, is a randomly chosen nurse, any one of the 37 nurses whereas group 2 is specifically nurse 23. And we would like to know what are the relative ratios of presence for those two. We probably are not going to have enough time to go into the details, and the details do get a little bit mathematical, but we can do that. That has been published, by the way. That is published work. I can get the relative risk. So once I have the relative risk, all I need is the information on the non-accused nurses. I no longer need that continuous line of dots. It doesn't tell me anything. It doesn't tell me anything, but I can work out the presence for Lucy Letby based on the presence of everybody else at a suspicious event. Now, that sounds sort of remarkable. It's not remarkable when you look at it closely at all, because she's not working in a vacuum. She works with other people. There are colleagues, the presence. We know a lot about the presence of the nurses throughout the year, because that's another issue which is very important here. We look at 25 events, but hang on a minute, we're actually talking about 1 year. And I wrote the number down somewhere. Let me just see. Yes, there are, in the year from the time the police focused their investigation, when they said, things need to be examined, that was June 2015, all the way through to the end of June 2016. And for that, we have a total of 792 shifts. So then the question is, okay, so which shifts were people on duty for throughout the whole year? So the problem is now it's what statisticians call a sampling problem. We only have a sample here, and I want to say something more general about the whole year that's taken place. Is it true, as the prosecution claimed, that throughout the year, babies were more at risk when Lucy Letby was on duty than when another randomly chosen nurse was on duty? We can investigate that, and we did, and we do. Yeah.
Now, can I just mention and point out at this point that we talked about this with Richard Gill in a very early interview. As you rightly started with nurse 1 and nurse 2 who were on duty for these supposedly suspicious incidents once. And you can see in the chart there's several others who are there for 1 or 2. And this is because they're part-time staff. So,
Yeah.
that ultimately that is ludicrous immediately, isn't it?
Well, I'm not sure if I would call it ludicrous. It's an important point. And if you want to do a more sophisticated analysis, you would certainly take into account the fact that we have a mixture. This nurse population is not homogeneous, it's heterogeneous, which is a very important point, because this is also true for the centres. The centres are not homogeneous, all having the same risk. Some are more at risk than others. There's no doubt about that. And I'm not sure what the initials mean, but Embrace, who analyze data concerning mothers and babies, and they show this, and they look at the various factors that could influence the rates of events in the different units, but these vary. So the units are certainly heterogeneous, but as you point out quite rightly, the nurses themselves are heterogeneous. Some, if they come from an agency, then they may be working very few shifts, and others full-time will be working many more. And of course, in the case of Lucy, we know she may have been the nurse working the most. She was certainly among those who worked the very most. So we've got a mixture. But what I'm doing is, and you can always do this, so yes, it's a mixed bag, but I'm just putting it all together because that's the information I have. And so I'm just describing it as a randomly chosen nurse, which means each nurse in this picture, apart from nurse 23, has the same probability of being selected, if you like, to be my random nurse. And that can sometimes will be a nurse who was present for 7 suspicious events, and sometimes it'll be a nurse who was there for just 1 event, but we have the whole distribution here, which I can actually show you. I can try. Let me try and show you. Is that popping up there, Chris?
Yeah, we can see that.
Great. So if we look along the x-axis, out of we use 61, we could use any number really. We're just counting the number of times the number of times present. So there's none at 0, the number of ones, the number of twos, threes, fours, fives, six, seven. We get a histogram, and then we fit to that histogram this law, which is known as a beta binomial law. It gives a good approximation. It's a probability law, so data scientists will be familiar with this, but it's just the best fitting law we can come up with for this data. We can work with the original data, but that is very onerous, and it takes a lot of effort, time, trouble, and computing power. So it's much easier. Mathematicians do this all the time. You come up with the closest fitting model, which is shown by the red line. That is the beta binomial fit. So that is the density function. In other words, if I want to know what's the probability of a randomly chosen nurse having between over 61 events in total, seeing through between 3 and 6, I just look at the area under the curve. That's how you do that calculation. So we can work things out from that. And that is, so all of this, the data we're using here to obtain this curve, does not use any information concerning nurse 23, Lucy Letby. That information concerning nurse 23 is removed, completely removed. So we only have the other 37 nurses. They provide the histogram, and then the red line is our doing. Well, it's not actually my doing, it's my colleague, Sean Devlin, who did amazing work and helped an awful lot here. He used programs which are available to data scientists to fit the best fitting curve to the data. And it gives a pretty good fit because there's not that much data actually. And then we can do quite a lot once we have that.
Yeah, there we go.
There we have it. Okay. So all this is showing is for the over those 61 events, 36 non-suspicious and 25 suspicious. This is the distribution, the estimated distribution, i.e. the probabilities of those different amounts. And that's what we get from that fitted distribution. And so we can see that 25 or more is very rare. So if we look at 61 events randomly taken throughout the year for the unaccused nurses, then the probability of being there for 25 events, it's almost zero. It's almost impossible. So we already have, for those guys, it's almost, that chart tells you it's impossible. Okay, now what about Lucy? So this is where it gets interesting. So what can we say about Lucy? Well, I'm going to stop that sharing and I'm going to try and share something else. Somehow you just have to open up the file, you go back, you open it. I think it works. So you can see these curves here.
Yeah, I can see the screen. Yeah.
Okay, Chris. So I need to explain this to you a little bit.
Yes.
But this information is exactly coming from what I just showed you, the beta binomial. It's exactly coming from that. So focus only on, I'm not sure if you can see my arrow or not.
Yeah,
It's dancing around the left-hand figure. Only look, forget the right-hand figure. Just look at this, the left-hand figure. Now, this black line for the left-hand figure is exactly the same information that is contained in that beta binomial fit. That beta binomial fit is what we call the density, the probability function. It enables me to work out probabilities. This is called the distribution function, which again gives me probabilities, but it's what we call sometimes survival function. What is the probability of being present at more than 0 events? 0 or more events. Well, it's obviously 100%. Everyone's going to be there for at least 0 or more events, and then you keep going. What about 5 or more? Well, we find 70%, out of that 61, and we just read it off. That is what a probability distribution function does for us. It just, you look at the x-axis, you read the number, and then it'll tell you the probability that goes with it. That's exactly what it does. That's no more, no less. But for those familiar with it, of course, this is just obvious. but it's also the bread and butter of statisticians. They work with these kind of things all the time. Now, what I'm going to do here is, instead of using the chart, I mean, actually, everything is based on the chart. All the information I have came from the chart on the non-suspected nurses. But for nurse 23, we know that that is full of biases, that we know that data was removed when Lucy was not there. They took those out, they replaced them by others. So everything concerning nurse 23 is of no value, which is interesting. Everything concerning the other nurses, though, is full of value, and we can use it to estimate our black line. Now, what we need is the connection between nurse 23 and everybody else. And we use a model, which data scientists will have heard of, called the proportional hazards model. And I cannot go into the details here. It's a very simple model. It's a bit like linear regression. Everyone's heard of the linear regression model, but less so proportional hazards. It's almost like an equivalent when you're dealing with rates. It's the simplest model we can use when we're looking at rates. And it can be completely justified. And that was in the paper that is published. We explain why that is the correct model to use here. And it enables us to look at the probability now for nurse 23, i.e. nurse Letby. What is the probability of her being present for 25 or more suspicious events? Well, we're just reading it off. And actually, we stop at 25 because that's what we had. And it's around 10%, which looks to be rather more than for everybody else. True. At the same time, 10% is a lot less than 100%, I think we'll agree. So the chart showing 100% based on a completely incorrect empirical calculation that ignores bias, yes, it comes out 100%. It doesn't have any real value. This one is much more carefully worked out. It uses all of the information in the chart, but only the information relating to the non-accused nurses, which we can rely upon that information. We come up with the best estimate we have for the probability of presence given the number of events. And that's the black line. And then we use the proportional hazards transform to obtain the blue line. And we end up with 10%. Okay, that's an estimate, which is easily shown to be vastly more accurate than the one presented, which just looks like a very rough and ready 100% estimate, ignoring bias. Now, the next step we did here, ignore the shading. I'm looking at the right-hand figure now. Ignore the shading, just ignore it. That's just to calculate means. We can ignore it. Just look at the blue line. The blue line is identical. It may not be obvious, but it's the same. It's the same blue line as here. In other words, nurse 23. That is the probabilities for nurse 23. What has happened to the black line? Well, the black line, instead of looking at all nurses, what I'm now looking at is all of those nurses who work in the top 25% of time on duty. So this will eliminate those who are very, the agency nurses or working short shifts. All of that has been eliminated, and we're looking at nurses working much more. Still, it's only 25%, and we can see nurse 23 still has an advantage, very small. It's very, very small. This is diminishing rapidly. And if I then look at the top, I think it was 5 or 6%, that gap disappears completely. And this was all in that paper that was recently published. So you can show that there is no evidence, that apparent evidence from the chart, which seems to show the nurse is always there when something goes wrong, is just completely wrong. If you are, that's because of the bias that enable them to come up with that. But if we use all the information we have on the non-accused nurses to get a very reliable estimate of presence for the non-accused nurses, and we use the so-called proportional hazards transform to find out what is the situation regarding nurse 23. Well, then there we have it. And now all we've done from this figure to that is, instead of looking at everybody as we did here, we only look at those nurses working in the top quarter of times on duty. So those are the hardest working. They're among the hardest. And if we look at the very hardest, then the difference disappears altogether. And we can see actually there's about 4 or 5, I think I came up with that, about 4 or 5 nurses working as much or more than nurse Lucy Letby. There's no reason to believe she was the most. And of course, even if she was the most, there's no reason to assume, the litmus test should not be, well, whoever is on duty the most must be our guilty candidate. And actually, what they did is not very far away from that, to be honest.
So, are you able to show us this thing of you can create a similar chart for any nurse? Is that something you're able to show us now?
I didn't quite catch that, Chris. I'm sorry.
Sorry. Are you able? I know you believe and can demonstrate that you could create a similar shift chart.
Oh yeah, I will.
Yeah. Can we take a look at that, please?
We
Because
can.
I mean,
we
essentially, this is the inference that we can make from this information, isn't it?
Let me do that. Firstly, let me do that. Firstly, a little bit of calculation. How do we get that? We work on the yearly basis. This is some technical stuff, just for the data scientists out there, some slightly technical stuff. We know how many hours in the year is worked, how many shifts. We know that. We know for Lucy, she was one of the highest, or maybe the highest. She worked 163 out of 792. Believe it or not, that information was provided by Dowie Evans. So he does come in for some criticism, and I cannot say I'm not one of those criticizing him, but he was quite generous with some of his time and provided that to Peter Elston, that information.
I mean, I should say he is doing that to defend himself, to be fair. Like, he was generous this time, but mainly he's doing that to defend himself, isn't he? So
it could be. I don't know. But we have that information anyway, and we have the average information. So what you can do the following. You look at the year, and you know there are 792. Let's just divide the year up into 792 shifts. And we will call them, a shift is a suspicious shift if on that shift a suspicious event occurred. I mean, you might say, well, supposing there is more than one. Well, okay, there might be, but it's unlikely. So there are a certain number of suspicious events taking place during the year. And for now, at least, you could analyze that if you wanted to. But for now, we're just going to assume that you see no more than one suspicious event on any randomly chosen shift. Okay, so now we have a question. How many suspicious events are there? Well, we know there are more than 25, and we've known that all along. We've known that there were, I think the defense pointed to 2 events which would have immediately come under the heading of suspicious, which were not in that chart. We also had David Rose and Peter Elston. They showed that there were 10 gaps in the original chart. The original chart was actually not 25, it was 28, of which 18, Lucy was present for 18 of those. So there was 10 gaps which were filled from the other list of non-suspicious. They suddenly entered into the suspicious chart. Well, we can imagine why that was, but anyway, we're just counting numbers for now. On top of that, we have the expert witness for the prosecution, Dr. Evans, who claimed also that he had another 25 events which did not enter into the the presentation or the police calculations, but he did say that he had another 25 suspicious events, and possibly more, including one case of insulin, by the way, which was very interesting because that is probably the only thing that people are leaning on to say there's something factual here. The gap between the insulin reading and the C-peptide ratios was something indicative of potentially exogenous insulin. That's been the argument. I don't know what happened in that particular case, but those were not used, and we can imagine various reasons. But there was 25 other cases. So we're looking at a certain number of suspicious events not being used, and I call that the pool of suspicious events. How big is that pool? I don't know. And here's where the data scientists listening to you, Chris, might they can do this themselves. It's easily done. We have 790, what did I say? 792 events is broken down into two categories: suspicious and non-suspicious. I don't know how many. We call it K. That's the usual letter that people use. K, suspicious, and 792 minus K, non-suspicious. And we take a sample from that. So if a nurse works 140 shifts, then that is the sample. They take their 140 shifts from that, that whole collection of suspicious and non-suspicious. So they will end up with some suspicious and some non-suspicious. Now, what we can do, all of this can be rescaled, of course, to what we see with our binomial distribution. But we can use all of that information to compare the theoretical sampling model, which again, for the data scientists, is just a hypergeometric distribution. I know most listeners will not know what a hypergeometric distribution is. It doesn't matter. But the data scientists will, and they will use it all the time. It's just a sampling model. If I sample from that, then once I decide how many suspicious events there are, I can end up with my beta binomial. And so what I do is I vary K until I get the most likely. This is what statisticians refer to as the maximum likelihood estimate. So this will mean, to statisticians, that will be just very everyday terms. But it means I can estimate that number. I can come up with an efficient estimate that uses all of the information in the table. Now, if I use that estimate, I have that estimate now, and so I have a collection. I'm going to call it a pool. I have a pool of what I'm going to call potential suspicious events, which will go into my chart, and I just start sampling, and I do exactly what they did. If I start looking, if I have somebody in mind, I can look down the chart, and when I see that, they were not there, they were not present, then I might look at it again. This is what they did. You look at it again, you say, well, you know what? It looked suspicious, but the more I think about it, it probably wasn't suspicious. That's exactly how they can do this, and they do it several times. And if we choose randomly, let's just choose randomly a nurse, and I did choose one randomly, nurse 34, and we use just the exact same procedure. And the important thing is, before I show you this, the important thing is it's the same data, it's the same information, the exact same information, the exact same time period, the exact same total number of shifts being considered, and the exact same estimated rates from the table of non-suspected. So everything is, as far as information goes, everything is completely identical to the original table. And what we're going to see, let me just check if I can show this. Am I showing? No.
No, no.
I think I was showing. I shouldn't have been. Let me try again.
Yeah, no worries.
Here we go. Are we seeing that?
So we can see, so this is nurse 34 shown as being
No,
omnipresent.
I'm stopping again. Let me try again. There is some problem there, isn't it? So I choose, and then this will work. This will work. I think maybe
Yeah,
not.
that's fine. Yeah.
Okay. So this is the chart we get. Now, does this look any less compelling than the chart we started with?
No, it looks exactly the same.
It looks, well, it isn't exactly the same,
Well, it
but
looks
it's
exactly the
you.
same in terms of there's one
Yeah,
omnipresent nurse, isn't there?
yeah. It's nurse 30. It's a different nurse.
Yeah.
Lucy Letby is nurse 23. This is nurse 34. It's using the same techniques. It's using this for every nurse involved there. I use the rates, just how often, apart from nurse 23, of course, but everyone, it had their presence. The rate was 1 divided by 25, 2 divided by 25. We simulate on the basis of that rate. We obtain that. And then we just iterate the charts in exactly the same way that they did. Only this time, I had a gut feeling, just like they did, by the way. They referred to that many times, their gut feeling. So even in the report of the Royal College of Pediatrics and Child Health, they said that the consultants pointing to nurse Lucy Letby was just based on gut feelings, and they were right. They were just based on gut feelings, and they themselves agreed they had no evidence. It was just gut feelings. So here, my gut feelings point to nurse 34. Now, if I was running this investigation and I had those gut feelings, and don't forget that the consultants worked with the police all the way through this. So this is what I would obtain. I would obtain nurse 34. I would show this to the jury and say, listen, I think it's, as Nick Johnson said, it's obvious, self-evident. It's nurse 34.
Yeah. And that could be done for other nurses as well, couldn't it?
Yes and no. Actually, yes. Well, it's interesting. You'll see something. You make a good point, Chris. Let me close that down. See if I can find. I did have another chart. Here we go. Okay. This is nurse 16. So I did do a random number generator, and this time I came up with nurse 16. So this is, oh, no, I don't, what am I doing here? Annually, I'm doing something wrong. Okay. Sharing the screen. Okay. Is that showing up?
Yes.
So this is nurse 16. Now, I do exactly the same process for nurse 16, but the only thing was the rate of presence for nurse 16 was small, very small. So even if I'm looking at the pool, the unused pool of suspicious events, I can never quite find enough. Actually, in the other case, I didn't quite find enough either. I had 24, but it looks almost as good. But with nurse 16, I couldn't go beyond 10. That used up everything, you know. It still looks impressive, but it doesn't look anything like as impressive as having 25. But so yes, your point is I can frame anyone I want, anybody I want. Some will look better than others. And of course, the ones that look the best are going to be the nurses who work the most. So working a lot and working more than everyone else is very hazardous in an environment like a neonatal unit. I mean, I know I shouldn't say such a thing, but if I had a daughter working in an environment like that, I would say don't. It's just too, certainly in England or actually anywhere, I'd say it's just too dangerous.
Absolutely. So I'm gonna play devil's advocate for a second now. So we've been through all these findings. It's very, very interesting. Um, and you've recently written a paper published in the journal Medicine, Science and the Law, and you argue that not only is the chart in the Lucy Letby case of little or no value, but charts of this nature should never be allowed in a courtroom at all.
Yeah.
So let's say there's a situation where there's a real serial killer. Could a chart such as this help identifying the culprit?
That's a good question. That is a good question. I honestly don't. I think it would require very, very careful analysis and a lot of questions about how the chart was put together. I really do feel that probably you need evidence. You know, the chart. given how easy it is to use a chart to point to anybody you want, my recommendation, and that was the recommendation in that paper, was to say they should not be used in the court. Very few people on a jury, you're not going to find data scientists, statisticians, probabilists, mathematicians. They're not going to be there. They might be, but even if they are, there'll only be one or two. I mean, they're probably not going to be there. And most people are just not going to understand it. And including statisticians, by the way, when I first saw the chart, I thought, wow, that really looks very strong. I thought I didn't, I had to look more closely and figure out, well, how did they put that together? And of course, once you realize how they put it together, you realize things like the suspicious event pool, events that they never used, then all of a sudden it's not hard to figure out how they can put it together. But generally speaking, that's not clear. And there have been a number of trials, a number of convictions actually, using exactly that chart, and it was used exactly the same chart was used in the Lucy Letby case, which thankfully was eventually quashed. But well, it was not in time for her. She died too, you know. So these wrongful convictions actually have terrible, terrible consequences for their victims. People need to know that, I think, you know. Yeah.
Can we say reasonably? So we have a chart here that's been produced by Cheshire Police, Dewi Evans, and paediatricians. So can we say reasonably that any such chart produced by people of that nature will almost inevitably be misleading and wrong? Is that a fair comment?
Well, we don't know what they did. We don't know what they did. What I would say is a jury should not be asked to rely upon that, because what is often forgotten, of course, is there is a basic principle here. And the basic principle is innocent until shown otherwise, you know, until proven otherwise beyond a reasonable doubt. And I don't see how that can ever prove that. I don't see how it can be part of that, because we know it might correspond to something, but it equally well might correspond to nothing. And that doesn't mean to say that the people putting that chart together are not doing so in good faith. They could well be doing so in good faith. In fact, I think it was maybe Tony Chambers, I think at the Countess of Chester, who did point that out. He said, "You're being driven by bias, a confirmation bias, which we all suffer from. Every human suffers from, or suffers, I'm not sure if that's the word, but is prone to, because it's so easy. You feel, so for instance, in a case like this, they feel, uh, I'm just hypothesizing, but supposing they really feel they've got the culprit, and now we're looking for evidence, and they think, aha, the chart, this is a good way. We look at things that really were a bit dodgy, you know, a bit dodgy, and and then we see whether she was there or not. And then, she was not there. Was it really dodgy? They go back, look at it again. You know what? It wasn't quite as dodgy as I thought, and it's gone. And by the way, I had it from Rachel Aviv's paper. I don't know if I can find it easily, but there was the comments of, he was asked, Dr. Evans, how did he define suspicious? And well, let me tell you, those definitions, it's so vague. I mean, it could cover everything, including the child vomiting. If you vomit in this way or that way, one way is suspicious, another way is not. How does he figure that out? We don't know, you know. So we'd have to know a lot more, a lot more. I don't think, put it like this, that chart should never be taken at face value. I mean, my preference would be, if I was to be giving advice to a judge and they really wanted to know, I'd say, listen, just don't allow the chart. That's the end of the story. That's what I would say. If he really thinks it might be useful, then I'd say you need to know how the chart was put together. How, and you certainly need to know a lot about the unused suspicious events. And there's going to be quite a lot of them. And the possibility that that name could have been in their head before they start, in which case they're always going to come up with that continuous line of dots.
Yeah, absolutely. So you've come up with some interesting new findings. Have you shared these with Lucy's barrister, Mark MacDonald, and should they be considered, new compelling evidence?
Well, I did talk to Mark some actually at the meeting in London. We're going back now in 2024, and we talked quite a bit. Actually, all of us. They were at the RSS, and we all ended up in having a pint, which is always nice. And I remember talking to him quite a bit about that, and he was very interested there. Now, I think at the time, and I didn't know as much. Obviously, Mark's a very clever guy, and he's not, of course, going to be saying everything in his mind. I think at that time he was very focused on the appeal to the CCRC, which makes a lot of sense, but also on what many people, including myself, felt was overwhelming evidence, and that was the report of Shu Lee. Shu Lee and the neonatal experts and all of those people who came together. I thought that was so devastating. I mean, I don't know, of course, how the system works anywhere, and less so perhaps in England. But I sort of thought, well, she'll be within the hour. There'll be an order to release Letby at least while they're investigating something, but that she would be no longer held, given that evidence. Of course, that's not the case, as we know, because poor Lucy is still there. What else does it need? I don't know. I've not heard from Mark since those exchanges we had. What I do know, I worked to some extent with Jeremy Larkin, who you may, I think you know Jeremy. Yeah,
No, I don't actually.
you don't know Jeremy.
No,
Yeah,
I don't.
he's a very interesting character, to say the least. He's what's the word? Admiral. He was involved in the Falklands campaign. So,
Okay.
um, what is the word they use? I wrote it down somewhere, just so I remember. Oh, rear. I don't know what that means, rear admiral, but what's
Oh,
the difference
actually,
between admiral and rear? I
oh,
don't know.
actually,
But he's certainly a very distinguished person, and somebody, of course, who was in his younger days prepared to really put his life on the line for what he thought was the right thing. So this is a person who is very seriously involved, and a person we all need to take seriously. Anyway, he put together another what should I say, file for the CCRC. And he asked me for my contribution to that, and I did. So that has gone into the CCRC. Now, I honestly don't know how the CCRC works. I really don't know. And I was surprised. I did say that to Jeremy. I said, well, how is it that we can have another application to the CCRC where when Mark McDonald already has an application into the CCRC? And honestly, I don't know, maybe you know, but I don't know how that works. Um, Actually, at the meeting in the House of Commons, I was at that meeting with Dame Vera Baird, who is the head of the CCRC. I wish I'd have known. I could have asked her how that works. It would have been interesting to know. My feeling is that they must somehow collate or compile or put these things together. I don't see why they would work on different files at the same time. I didn't even know it was possible to have different files, to be honest, until Jeremy, contacted me and said yes, and I included my part. So they do have it with the CCRC. I suspect logically that they would put these files together. So in other words, I know Mark's file was a very big file. It's over 1,000 pages, I believe. And he had all of the evidence coming from these neonatologists. So that is fantastic. I think Jeremy's is much, much shorter and sharper, I don't know, but certainly shorter. It has my paper in there, and it has the chart in there, and it has all the criticism of the chart in there. So I think the CCRC, these are the ones who will make the decision. They do have all of this information.
Okay, well that's good to know. Um, so I want to discuss with you the ruling out of initial cases from the court case. So we have Dr. J. Ram and Dr. Brewery going to Cheshire Police in May 2017, and at that time they were citing multiple deaths that ultimately were not part of the indictment. I would argue that doesn't say much for their medical competence, but that's another matter. So a lot of the impression that they had during this period where there is an elevated number of deaths was rooted in this idea that all these deaths are suspicious. Um, and then they turn, even Dr. Evans can't find a way to make them suspicious. And then another aspect is that there were an extremely high number of multiple births combined with a challenging acuity of infants. So ultimately, what you're left with is 7 infant deaths in the court case, a little above what they've had previously, but nothing out of the ordinary considering the context. So I would argue that this is all contextually explicable. Do you
Yeah,
have any thoughts on that?
I do. I agree with you completely. I agree 100%. What I could add to that is that it is extremely difficult. I mean, I can say if you wanted to do a thorough statistical analysis, taking into account the degree of certainty of what constitutes the first thing you're going to do as any kind of scientist, the first thing you have to do is define things. What do we mean? And this is one of the problems we have here. What is meant by a suspicious event? Can can we write it down? And I think Rachel Aviv said that she contacted Dowie Evans. She asked him for a definition. He couldn't get a sharp definition. It's a very, very vague definition, to say the least. And so, of course, once you have a definition like that, then that allows exits and entrances, as Shakespeare might have said, but it allows for that. And it's very hard to know. You know, the end result really does not correspond to anything very concrete. And certainly the chart is, we're not quite sure what it's showing us. But having, what should I say, events removed and other events added as we go along in time. And we know even the course of death, actually, that's even more surprising. The course of death also changed as they discovered certain things. There were several changes in the course of death. They say, must be this. Oh, no, actually, they discover that I think one baby, they said, must have been poisoned. They said, well, no, actually, there was no added chemical, there was no possibility. So then they changed. Oh, well, it must have been something else. But what does that mean? If I don't know. It does not correspond to what we're used to in a murder. In a murder, somebody's lying down in the street with a knife in their back. Um, if you say, "Oh, that was an optical illusion," there wasn't a knife in their back. Well, somebody must have shot them. I mean, you need something concrete. You're just making it up as you go along. And actually, that typified so much of this case. They winged it from word. I think what happened was, the accusers, maybe in good faith, but Jairam and Breary, they this just took them along. They jumped onto this roller coaster. They couldn't get off. They couldn't get off. It got worse and worse and worse. And the police, of course, just really did a terrible job. They just dragged everyone along with them, and there's nobody could say stop. You needed somebody to say stop. Like, can we just sit down and look at all of this calmly? And that seemed to have never happened. And seemed to have never. There seemed to be a permanent state of hysteria surrounding the thing,
Mm.
and other motives which are very bizarre and strange. I mean, everyone has their own axe to grind, and that is very troubling. I always say, in the judicial system, very troubling. One of the things I didn't know I missed when I read Rachel Aviv's paper in the New Yorker. I missed the bit about the Cheshire Police preparing a video for Netflix. I just didn't think anything of it. But of course, now we have this Netflix, which is the result of that. A couple of years down the line, they have this video, which is shame. To be honest, it's truly, truly shameful right from the word go. I should have noticed that when I read her article. What are the police doing? Is their job to be selling for who knows how much? But is that the job of the police? So already they had their, what should we call it, their publicity, their filmmaking operation going along, and who knows who gets to have the most say in any of this. They're not doing the job that we imagine the police to do, at least. That's for sure.
Mm. Yeah, absolutely. I agree. I wanted to talk to you a little bit about outlier results in large data sets. So I remember discussing this with you when I was interviewing you previously for my book, and I mentioned the example of blackjack, where there's been a computer model done with billions and billions and billions of hands, and the computer discovered that if you play blackjack for long enough, you definitely will lose whatever you do. There's no strategy that will help. The only thing that can help you is if you know what card's coming next. And that's why people try and count into the pack. And that's why they try and chuck you out if you do that because they don't want you to win.
They know, yeah, of course.
But if you just play a strategy without knowing what the card comes next, you will lose. However, within those billions and billions of hands, if you have a short period of luck, then you can win and you'll get a spike and otherwise you'll just inevitably lose your money if you play for long enough. So that's an example of a system where you can have outlier results in what is a large data set. So in a massive system such as the NHS, such outlier results are inevitable.
Yeah.
So can you discuss this and explain this some more?
They are absolutely inevitable. And of course, you're trying to tease them out. By definition, since they're inevitable, they ought not really be called an outlier. It's hard to say. It depends what we mean. Once again, do we need some kind of a sharper definition for what we understand to be an outlier? But it's absolutely the case that, in fact, the Embrace data tells us a lot about this. You look at these centres, you can look between centres or within a centre. You take one centre and look at it over time. One year it's doing quite well, the following year it's not doing well at all. Now, sometimes we can identify the causes there, but sometimes they're not so easily identified. There are random terms that get mixed up. There's, of course, year in, year out, the acuity of the babies that they're receiving, the gestational age of the babies, the weights of the babies, these vary. They cannot be identical from one year to the next. Some years they are hazardous for the baby, and the years they look better for the baby. So that can give something of an explanation to the outcome that we see, which changes year in, year out, but also looking across centres, which change year in, year out. And then if every year we just list the worst performing centre to the best performing centre, we cannot assume that the worst performing centre, there's something happened there. There's got to be something really strange going on. They just happen to be the worst. I mean, in a system in which they all really are identical, then you still expect to see differences, and you can rank them from worst to best, and the worst will look bad, that's for sure. But maybe there's nothing so unusual about that. All of that can be studied. All of those things can be studied. That is the bread and butter of statisticians. We call those extreme values, outliers possibly. And it's a very tricky and not an easy subject, to be honest. You can make headway if you assume all of the centres are independent and they all perform the same. Everything's, at least on the surface, everything is the same. Then you're still going to get a ranking from worst to best. And that situation we can analyse easily. But it gets more complicated when they're not all the same. They may be independent, but some centres have really good facilities. They have a much better nursing staffing ratio, more qualified. There's all sorts of other things that you need to take on board. And then it gets very complicated. It really gets complex, ranking the worst to the best, because you might think the best will always come out on top, and it's just not true. It's not true at all. Sometimes the most average will have the worst performance for that year, and it's very challenging actually. So I would say that if you're trying to analyze all of this, and people do, the Embrace people work very hard. They have excellent summary results of what they do. And so there are people that try to do their best to analyze this data, but it's very complex data. It is complex. And I don't think there's any hope of a jury sitting down, looking at a chart or something like that and saying, oh, clearly this shows, this shows criminal activity. That's impossible, essentially.
Hmm. I think there's two things at the heart of this. So they decided we've had a spike in deaths, therefore it's suspicious. And in fact, as we now know, that spike can be explained by, raw sewage, Pseudomonas, clear evidence of sepsis, other infections, understaffing, underskilled nursing, no neonatologist on the unit, lack of skill, challenging acuity of babies, too cramped with not enough cots. They've knocked down the entire neonatal unit they were operating in because they know it's inadequate. There are regional organizational problems. Babies are being transferred all over the place. There's transportation issues. When you put all those things together, that's an obvious explanation for what occurred. And then the other thing that I'd like to highlight is that imagine if every single year in the NHS you found out the neonatal unit in which there were the most deaths, and then you just said, right, we will now investigate that neonatal unit and assume that there might be a serial killer there. That would obviously be preposterous.
Yeah,
But effectively, that's what happened in this case.
effectively, that's what happened. While ignoring at the same time what was taking place right next door in the maternity unit, because they also, the rate of stillbirths, there were problems there, which is interesting because all of those factors you described are to a more or greater extent, they're shared. Many of those are shared. So, of course, it's not entirely surprising that things going wrong in the neonatal unit may also be mirrored by what's happening in the maternity unit. And we know that things didn't look good in the maternity unit there. So in a sense, you could take that as a variable to adjust. We could say, well, listen, if we have a maternity unit, let's use that as a variable to try and explain, at least to some degree. But all of those other factors you mentioned, of course, they are all relevant. And it's the kind of thing that statisticians can work with. But you're talking a whole thesis, maybe several theses to try and do a very good analysis of it. It's not straightforward. It's not straightforward. It's work that needs to be done. And from what I've seen from Embrace, they are doing their best to analyze that kind of data, but it's not very easy to try and take absolutely everything on board because some of these variables are highly correlated. So you don't need to take both of them on board, just one or two. You know what I mean? The whole thing becomes quite an exercise in model building, which of course is the bread and butter of many statisticians, and they know how to go about doing that. But it's not something you can do in an afternoon. It takes time, and of course you need the information as well, which is not always available.
Absolutely. So I'm going to ask you about an article. Let me see if I can put this on my screen just for the benefit of viewers. So it's this article by Lucy Letby police ignored other baby deaths on the unit. So not only did they discount cases in the initial court case because they were outside of the period that they were examining, but also they told parents, we're not going to examine the circumstances surrounding your infant because it's just outside of our period, and so therefore you can go away, basically, at this time. So I just wondered if you had any response to that, or if you could explain the significance of this from a statistical perspective and from the chart perspective.
Well, I'm not sure if it's a statistical question as such. It seems to me to show a certain lack of seriousness on the part of the police there. They have something that looks so it could explain a lot, and they don't want to know for the simple reason, or it appears to be the simple reason, that they already have their case. They think they have a case. They think they can pursue that. They don't want to know anything else that may add to their case or take away from it. They just don't want to know. But that means if those other cases are not being investigated. And the same applies actually to hospitals. If you look at the counties of Chester peaked. If you look at the Embrace data, they were a peak in 2015, but in 2014, they were not. They were not. They were not a peak, and it was somewhere else. And the somewhere else, I've forgotten which hospital it was, but the other place was actually higher, had a higher peak than did the Countess of Chester in 2015. So surely they should be investigated. As far as I know, no investigation was taking place there. So clearly, the police have been somewhat selective in what they are looking at and what they're trying to obtain and describe. So it's hard to know what to say. Really, statistics, you need to know what the question is. You really need to know what information you can obtain to help you address those questions. And yeah, a relevant question would be, what about all of this other data? Yeah, that's a relevant question for sure. Yeah.
Yeah. But if they'd drawn these other cases in, and they couldn't place Lucy Letby at the scene. Or
Exactly.
that could
Exactly.
have that would have torpedoed the whole chart, wouldn't it?
Exactly. That's what they don't want.
Which
Actually,
makes
I made that point. You just put one gap in that chart. They
mm,
have to have a complete row because one gap, how do you explain a hole in the chart?
mm,
That means it's suspicious, but she wasn't there. Well, there's only two explanations. Either maybe someone else, maybe it's not suspicious and you're getting it wrong. Well, once you admit you can get it wrong, all of a sudden the whole chart loses its weight. So they really work hard to get a continuous row of dots. Otherwise, the whole thing falls apart.
absolutely. So I want to just briefly discuss the situation with Professor Jane Hutton, who we've had as a guest on the channel, where she was commissioned to provide statistical evidence. Then it seems that the Crown Prosecution Service instructed them not to pursue this, and ultimately her contribution was no longer required. So what do you think about that?
Well, I do think everything appears to me, at least, to indicate that the police were not really looking, at least not for most of this investigation, to unravel in some sense what was going on. What is the truth? They they seem to be entirely focused on one individual and what can we do to put together a case to have the strongest case possible against that individual. I mean, in fairness, that is to some extent their role. Certainly, the prosecution service, their role is to build the most damning case they can against the person that's accused, and then say, okay, to defend the person, they have a defense team, and the defense team will do everything they can to undermine the prosecution's case. So, in some ways, the police should be different to the prosecution, but actually, in practice, I don't think they are that different. And so they tend to see the same thing. The goal is to stack up as much evidence as they can against the person. So, my feeling, I don't know, you'd have to ask Jane, but I suspect that they felt, or the CPS felt, well, we have enough. We have enough. Let's just let and related to what you just said about those extra cases, let's not dig any more deeply because we might undermine our own case. It already looks pretty strong. Uh, we have a lot of things that look good. Let's stick with what we have. I don't know. You'd have to ask them, have to ask Jane. Why did they do that? Because my suspicion is their their motive and their role is not to reveal the truth. Their role is to get a conviction.
Yeah, absolutely. We can't ask them because they don't answer any questions. So I mean,
Okay.
I've tried.
They do
Um,
make movies though.
yeah, and I mean the Crown Prosecution Service as well. They don't answer questions. Um, so then there's this bizarre decision of the police in which they decline to appoint other experts when advised to do so by the National Crime Agency because Dr. Evans tells them not to do it. And then on top of that, there's this extraordinary selection bias where they involve Brewery and JRAM in the selection of cases when it's well known that they're the accusers of Lucy Letby and they've walked into the police station and done that. So
Mhm.
could you give me your views on that as well?
Well, again, I don't see that as being statistical. It seems to me very wrong on just a simple, intuitive basis for an average citizen. How can the accuser become a part of the police investigation? And of course, as far as Dowie Evans, not only was he part of the police investigation, he was also an expert witness for the jury, for the court. I'm sorry. So it seems astonishing that these conflicts of interest, I didn't know it was possible. To be honest, I didn't know those things were possible. I thought they were not possible. I don't know if this, how it works in the US. Be interested to know. I should ask some colleagues there. Can you get away with that in the US? Such obvious conflict of interest, and maybe in the UK it's okay. It is shocking, to be honest. It is a little shocking.
Yeah, I agree. I agree. It clearly shouldn't happen in this country. Obviously, they've been able to do it for some reason, but it should never have happened. Um, I want to talk about one last thing before we go through a little diagram that I've made. So, Dr. Evans told police that this is quoting his own words. if you harm a baby, it will deteriorate there and then. So I also identified a time and date when each had probably been harmed and told them they needed to find out who was on duty. If they found the same person was there during lots of incidents, they'd have a suspect. So not even all the incidents now, lots of incidents. So I have argued that this makes the identification of a suspect virtually inevitable because
Yeah,
it's not even all the incidents, it's just lots of incidents. Do you agree with that?
I do. I do agree with that. And it also tells me that he was working for the police. He wasn't hiding this. He was not there in any independent capacity. He was there to make a case. And I think he himself said, referring to all those many cases he'd been involved with over the years, he'd never lost a case. It's supposed to be an independent witness. You're not supposed to be winning or losing cases. But I think he claimed that he'd never lost a case. So, so obviously that is rather worrying about his role there. And I'm sorry, the first bit I lost the drift of what was the first point you
Yeah,
made there, Chris?
just these assertion that if someone is around for lots of incidents,
Oh yeah, yeah. I'm
then the
sorry. Yeah,
suspect.
yeah.
Yeah.
It's come back to me now. Yeah. So that also tells me that he must have known something about the mechanism of building a chart because it's not the first time, and there's no reason they wouldn't know about that. I think the charts have been built in other cases and involving in pediatrics. How would they not know about that? And so I think it suggests that the idea of building a chart is already there in his mind. It sounds like it.
Yeah, I mean, I think in my book you've described it as a blueprint to convict someone, essentially.
Yeah,
Um,
it sounds that way. It does.
yeah.
Yeah,
So we're going to look at a diagram now that I've created. I'm going to go this with John and also for the viewers' benefit, right? So we can see this on the screen now. So we now know all of this happened. So it begins here with the pediatrician. So the pediatricians, Brew and J-Ram, they go to the police on the 15th of May, and also they have some documents that they send to the police in correspondence, and they
yeah,
say, "Oh, we suspect Lucy Letby." They might as well just have said we suspect Lucy Letby because they identified her in that meeting, but they
yeah,
also fed all the dates that were to be investigated to the
yeah,
police. So the police then restricted the investigation to those dates and that suspect. Like we know that from their internal documents that have now been leaked. So then the paediatricians that have just gone into the police station, they then select the cases for the police. The police then feed the dates and the suspect to Dr. Evans because they basically tell Dr. Evans, there's a nurse suspect, and they definitely explicitly feed the dates. And then we see comments from Dr. Evans where firstly, definitely only examines this period because he only asked for the notes relate to this period that they've identified here and that's been passed all along. And he definitely has the idea of a nurse being in mind, in my estimation, because we're going to examine this in a future video. But he makes these comments about where is the nurse, where's the location of the nurse relative to this, and so on. So then Dr. Evans does his shenanigans, and then he tells the police, as we've just said, to go back and find out who was on duty for lots of incidents. So the police then go back to the paediatricians to find out who was on duty for the period that they themselves have outlined. And then the paediatricians feed the suspect and the dates back to the police. And that is literally the process that has occurred in this court case. And we now have all the documents to prove this and to demonstrate this. So I just wanted to show that and to show that to John as part of this video because it's quite incredible what has occurred. Do you have any kind of further comment on that?
Well, given that you outline it perfectly, given that if we have an unused pool of suspicious events, which we know we have, then the chart I showed for nurse 34, it's easy as pie, or any nurse. You can do that then for any nurse. So essentially, the consultants decide who they want to blame, and that's it. And then you go round the circle a few times, and you end up with the chart for
Yeah,
whoever they've chosen. Yeah.
absolutely. Um, so I've just got a couple of general questions to finish. I know that you've got a view on the parents, the infants from Lucy's case. So we're often criticised for upsetting the parents, or allegations are made that we've upset the parents even by the police in their recent response to the Crown Prosecution Service when it was actually them who'd upset the parents. So I know that you have a view on this. So could you explain that, please?
Well, it's happened to me several times. When several times, right from the word go, and even with articles presented to journals, and they've said openly, this is too sensitive. They said directly, this is too sensitive. We cannot take a position on this. Or they've said directly, this may be upsetting to the parents, so we don't want to. And these are scientific journals, which is taking a view they shouldn't take, I think. So I think that maybe that's eased up a little bit. It was obviously used. I mean, of course the parents are going to be upset. How would they not be upset? They're really quite life-changing events have happened in their own lives, and they're trying to put their lives together and move forward. There's no doubt about that, of course. So they are in a tricky position, and we sympathise. There's nobody that does not sympathise with the parents. That's obvious. But I do believe that that has been cynically used by people to shut down any kind of indication that there may be something wrong in this case, and it's been used systematically and, quite cynically. It feels that way to me. And I think if I don't know any of the parents, and I'm never likely to know any of the parents, but if I had anything to say to them, of course, was number one, certainly would be, yes, everyone sympathizes with everybody. But I would also say, listen, Nurse Lucy Letby cared. She didn't just care, but she gave her everything to help your child. So you probably have an opportunity to return that, to help her. She needs help right now. And I do think if some of the parents spoke out, they cannot not know. I think they come under a lot of pressure from all sorts of avenues. Certainly their lawyers and maybe others will be uh, putting pressure on them not to say anything, but some of them know that there's something wrong here, and they don't. All they need to do is to say, we want this looked at more closely, because that's it. I think the public has an opinion that all of the parents are outraged by the fact that anyone would suggest she's innocent. I cannot believe that, because the people who are saying something's gone wrong here, they're not crackpots. They're very, very sane people. A lot of top scientists, top medical professionals in the field, absolute leaders in their fields, no end of them. And then we have parliamentarians. We have a David Davis. Was it Andrew Bridgen? I think the name is. I'm not sure. I don't follow politics that closely, but I suspect there's more people in Parliament have been involved. As I said, we had Jeremy Larkin, who is a Rear Admiral, retired now, of course, but very, very, very senior, serious people who don't get involved for no reason. So that does not mean to say that they're correct. Just because you're senior and you have a stellar career, that does not mean to say you're correct. Everybody can be mistaken, of course, but there's so much information now out there and available, and it cannot have escaped the attention of the parents, despite their past suffering, that I think if one or more of them were to speak out, only to say, can we look at this? Only to say, the CCRC, maybe they should ask a court of appeal to look at this. That would be, I think, of great, great service.
Hmm. I think what I would add to that, which I agree with, is that I'm sure this comment will be directed at me at some point. Obviously, I would be way down the food chain of people that they would speak to, but I'm perfectly happy to speak with the parents. And I'm absolutely certain that Sir David Davis, Mark McDonald, the experts from the case, people like John, we would all speak to them and explain the situation. And it's important to note as well, I made a video about this recently, that as an example, the parents of child D would have a very good claim for negligence from the hospital. And I feel that they would probably want to know about that. In fact, they were beginning to pursue that, as far as I'm aware, before it was decided that Lucy Letby was to blame for everything.
Yeah.
So I think that no one sets out with the intention of upsetting people, and we recognise and acknowledge that it's been traumatic for the parents. But Mark always makes this comment about maybe if they feel angry, that should not be directed at Lucy Letby. It should be directed elsewhere. And I mean, I agree with that.
Yeah, yeah, yeah.
Um,
Also, sorry, come on.
Please continue.
Yeah, no, also what I was going to say was for things like this, it helps to learn. It helps to learn maybe things can be done to improve and to help, children, new babies in similar situations. Things can be done, some of them easily done, some that may require greater investment. But if we don't have the truth of it, then we can never make that kind of progress. So it is very important that we get to the bottom of it, get the truth, and it's in everybody's interest, including the parents. Yeah,
Yeah, and I think that there can't just be a scenario where when any time anything inconvenient happens in the NHS, it just gets brushed under the carpet and someone scapegoat gets blamed for it.
yeah,
I mean,
yeah.
that's calamitous, obviously.
Yeah, yeah, exactly. Yeah, yeah. It means that things cannot improve that way. You would like to hope that things can improve socially. We have there are problems. How can there not be problems? There are in all sorts of sectors of society. We'd like to make some efforts to improve them. Certainly, the hospitals do a fantastic job. They all work like crazy. We all appreciate what they do, but certainly there has to be room for improvement. And unless we are at least we begin to acknowledge something has gone wrong, then we cannot make progress on that front.
Absolutely. So the last question is, you're the first person I've interviewed since this Netflix film came out. I just wondered if you'd seen that and if you have any reflection on it at all.
I've not seen it. I heard about it and I decided I was not going to see it. And I still won't see it. So even I do look, obviously I'm interested in and would like to help Lucy. And I do see there are online content about Lucy, about the case, some angles. And so many of them start with that scene of when they come and they take Lucy away. I cannot bear to watch it, so I switch off straight away. So I don't watch these things. And from what I understand from colleagues in the US that told me about, they actually thought the Netflix was quite good. I mean, they said the first hour was really bad, but the end of it was quite good. It sort of did talk about the case. But at the same time, I understand there are some horrific scenes in there, and already I just don't think I could bear to see that because I think it does. Actually, I think there's a lot of stuff out there on the internet. We never used to have things like this. They used to censor things on the TV. I'm not saying we should censor everything, but you would never see graphical violence and real injury done to people. Now you see it all the time. I mean, real injury, not some simulated injury. And that was how I would see the Netflix thing. That my understanding is they sort of horrible, really, everything they did. And now reading Rachel's Aviv article again, they were filmed. They were really preparing, like some of these YouTubers do something nasty and do some online prank to get views. It almost looks like that, They're setting the whole thing up when there was no need at all. Lucy said she was prepared to talk to them anytime they had questions, she would have gone and talked to them. There was no need for this dramatic scene, but they were. It seems that way. It seems as if they had in mind um, they wanted something dramatic. They were almost part of it, almost as though Netflix advised them, we need something like this. And they said, okay, great. They went in. I'm not accusing anybody. I don't know. So I don't want to accuse anyone. And I'm not going to watch it because I just cannot bear it, to
I
be
wouldn't
honest.
I wouldn't recommend it. I
Yeah,
mean, it was
yeah.
traumatic for me to watch it, and I had to review it. I said I
Of
would.
course, yeah. Yeah.
That was not an enjoyable day, but
Yeah,
it had to
no,
be done. So
that's what I figured. Yeah, that's what I figured. Yeah. I mean, you're in a different position. Obviously, you're writing a book, you have your channel and things like that. I'm just focusing on the charts or the statistics. So, and I just find it it's just too cruel, too cruel. I think humans should not be that cruel to one another. Maybe that's idealistic, but I think they should not be so cruel.
I agree. I agree. Well, that's absolutely great. Thank you so much for joining us today, and also you've always been helpful to me in the background that people don't necessarily know about. So when my book comes out, John features quite prominently in that book, so you'll hear a lot more from him in there. And yeah, thanks for joining us today and sharing your knowledge and expertise. It's very much appreciated.
It's been great talking, Chris. I appreciate it, and certainly good luck. Good luck with the book. I'm looking forward to it.
Thank you.
Yeah, yeah. Bye, Chris.
Bye now.